doing 7.3. We're going to be talking about tangent lines on circles. And once again, you should have learned this stuff in secondary 2. We just apply it in a more advanced setting in secondary 3. Okay, so if we have a circle, a tangent line is tangent to a circle if it intersects a circle at exactly one point. So everybody, do you see how this line is made and it only touches the circle in exactly one spot? Okay, that's called a tangent line. Now notice it's touching at one point, point A. That's called the point of tangency. So just keep that in mind. So it's not a tangent line if it crosses the circle more than once. So for example, this is not a tangent line. It crosses in 2 places. Therefore, it is not a tangent line. Does everybody understand? So we can sit and draw tangent lines all day as long as they only intersect the circle in one spot. Okay, so now there's a couple things to know about a tangent line. If you have a tangent line, then if you drop a radius to the point of tangency, it's going to create a perpendicular angle, which means 90-degree angle. So from the radius to the point of tangency, that one point where it touches the circle, is going to create a 90-degree angle. Does everybody understand that? Okay, sweet. So if you understand that, then look, if I drew a triangle like this, wouldn't we have a right triangle? If I drew a triangle like this, wouldn't we have 2 right triangles? Yep. Okay. Okay, so next thing to know about tangent lines. If you have 2 tangent lines, so look right here. Do you see how this line's touching at C? And it's only touching in one spot. This is a tangent line. We have another tangent line point touching at point A. Here's our other tangent line. And those 2 tangent lines share this angle. Does everybody see how they intersect at that one point? Okay, then these tangent lines will be equal in length. Okay, so that's just one thing to know. Alright, so just keep in mind, guys, if I was to drop from the radius down to the point of tangency, what degrees is it going to be right there? 90. Didn't we just barely learn that, right? From the radius to the point of tangency, it's a 90-degree angle. So if I drop this radius down to here, what angle is that? 90 degrees. Okay, good. Okay, so now we're just going to use that to solve. That's all we're learning today. Now we're applying it. So we're using that to solve for x. Okay, one of the biggest things to help you on this ACT coming up for you guys in the next few weeks. Okay, solving for x. So first of all, x is an angle, this angle right here, right? So we've got to go through and figure out what we know. So everybody, do you see how this is a tangent line since it only touches in one spot? From the radius to the point of tangency, it touches. So that would be a 90-degree angle right there. Am I correct? Yes. Now, isn't x pretty simple? Yes. What do all 3 angles of a triangle add up to be? 180. So 180 minus 90 degrees minus 25 degrees. And we know that angle. What do you get? Guys, if you help me out, the lesson goes 20 million times faster. 65. Okay, are we good? Yeah. Okay. So looking at this one, solve for x. So x is this angle again. In this one, we don't really have a triangle-looking thing, do we? No. But look, isn't this a tangent line? Doesn't it only intersect in one spot? Yeah. So here's the radius drop to there. That creates a 90-degree angle. Now look at this is another tangent line that only intersects the circle in one spot. So from the radius down to there is 90. Well, don't all angles of a polygon add up to be 360. So we'll take 360 minus 100 minus 90 minus 90. $80 degrees. Questions? Okay, so solve for x. So with this one, we're solving for x. So we're going to set up a true statement, which is actually what we did in all these problems. We set up a true statement and solve for x. So let's look at this. First of all, what are we looking at here? So I'm going to ask you, is this line a tangent line? Is it?
No.
Yes.
But technically, if we extended it, wouldn't it intersect twice? Right? So this would not be considered a tangent line. Okay, but looking at this line right here, doesn't it only intersect at that point? Is it going to continue off this way? Okay, so that's a tangent line. So a radius drop to there will create a 90-degree angle, right? Okay, don't we just have a right triangle now?
Yep.
And we know how to solve right triangles, unless, if you don't, you shouldn't be in this class, you should be back in secondary math 1. So, right triangles, so they're all sides, right? So side 1 squared plus side 2 squared is equal to the hypotenuse squared. The hypotenuse has to go on the outside of the equation, right? So we have x squared, side 1 squared plus side 2 squared equal to the hypotenuse squared. Do you all understand why I have to put 12 squared on the outside of the equation? Hypotenuse means across from the 90-degree angle, guys. That's the hypotenuse. Okay, so solve for x algebraically. So we have x squared plus 100 equal to 144. Am I correct?
Yeah.
So then we have x squared is equal to, we'd subtract 100 when we would get,
444.
then we take the square root. X is equal to the square root of 44, right?
Yep.
Now I do expect you, my secondary 2 students can do this, so you should be able to do this. Not to do, so let's type it into our calculator. What do you get? A decimal, right? So you should be able to, at this level, break this down by hand. If you can't, you should go back to secondary 2. Okay? What's 44? What are some factors of 44? 4 times 11. 4 breaks down into 2 times 2. Now if you have groups of 2, not 2s, but if you have groups of 2, you can pull it out, right? Because of the square root. So we pull out 2, what's left under the radical? So we have 2 square roots of 11. Now I want the decimal answer as well. So you'll type in 2 square roots of 11. 6.6. So the reason I make you do it is because you could see either or answer if it was a multiple choice test. Does that make sense, everybody?
Yes.
Okay. Couple more, then I'm just going to let you work. Okay, so we have this triangle. First of all, you have to decide, do I even have, what do I have here? So looking, once again, that's not a tangent line because if we extended it, it would cross twice, okay? This, however, right here is a point of tangency because that's a tangent line. So that creates a 90-degree angle. So now we're going to set up a true statement and solve for x. So we know side 1 squared, which is x squared, plus side 2 squared, which would be 12 squared, right, is equal to the hypotenuse squared. Well, let's look. What the heck is the hypotenuse? X plus 8, right? If we did x times 8, that wouldn't make sense, right? When we add up this amount plus this amount. And if this is a radius x, wouldn't this be a radius x? So wouldn't our hypotenuse be x plus 8, the hypotenuse all squared? Okay, so then from there, let's simplify, let's solve this algebraically. We have x squared plus 144 is equal to, can I just square that? No, that's like breaking the most forbidden of all forbidden rules of life. Nope. What's that the same thing as? X plus 8 times x plus 8. Does everybody understand there's a plus sign in here? If you just square that, you're breaking the most forbidden of all forbidden rules. Okay. So we multiply this out. That's x squared plus 8x plus 8x plus 64. So on this right side, we have x squared plus 16x plus 64. And that's equal to this side, x squared plus 144, right?
Yeah.
Now we're going to solve. You can solve this many, yes?
Did you square root it instead of?
Then that's going to give us a huge distance. Yeah, you could, but then you do it to both sides of the equation, right?
And that would take out both of them.
Nope, because if you square root this,
If you square root the top,
no, because you can't. Nope, here's the thing. Just like you can't just square that, you can't just square root that.
but the top one,
The
if you
top
square
one,
root one side,
You can't, okay, if we square root this side,
And then you square.
square root that side, wouldn't those come out?
no,
Why not?
because I'll explain why. So here's why. Okay, so just like you guys do understand the rule that you can't just square that, right? Everybody, you know that wouldn't be equal to what it really would be. So you're saying if you know that you have, see this plus sign? That's why we can't do this, because really what we have is this. X squared plus 12 squared raised to the 1/2 power, right? Can you just 1/2 power this, 1/2 power this? No, just like you can't just square this. Does that make sense, everybody?
Yep.
So that's why we can't do that. Does it make sense? No?
Yeah.
You do get it. Because if you understand the fact that you can't just square this, then you should understand the fact that you can't just 1/2 power this, 1/2 power this. Which is what the square root is, technically, right? Okay. Great questions. Great, I'm loving these. Okay. Sweet. So from here, we'll go through and solve for x algebraically. So I'm going to bring my x squareds together. So I'm going to subtract x squared, subtract x squared. So we have 0, and then 144 is equal to, oh, doesn't that cancel out too? Phew. So we have 16x plus 64. Now isn't it pretty easy to solve for x? So 144 minus 64, right?
Yeah.
So 144 minus 64. 80 is equal to 16x divided by 16. So 80 divided by 16 is 5. X is equal to 5. Questions?
X is equal.
Well, that's our radius, right? So the hypotenuse would be 5 plus 8. But, yeah. Okay, go. 1 through 9. And let me give a very basic example. Let's say this is 3 and this is 5. And I say find x. We have to set up a Pythagorean theorem for this one, right? We're missing sides. Side 1 squared plus side 2 squared equals the hypotenuse squared. Doesn't have to go on the outside. Okay? So let's solve for x. X squared plus 9 is equal to 25. Am I correct? Then when we subtract 9 from both sides, we have x squared is equal to 16. Are we done? What do we do? Square root both sides of the equation. X is equal to 4. Okay guys, so you have to be able to set the Pythagorean theorem problem correct. Okay. So moving on, I mean, not a whole lot different. I'm just going to show you one example, but you could do this one without my example. So it says, is the line tangent to the circle? So looking at this, it wants to know, is the line tangent to the circle? So first of all, if it is tangent, don't we know for sure that this is a 90-degree angle?
Yeah.
If it is tangent, won't that be 90 degrees for sure? So if that's true, then that is a right triangle. Therefore, the Pythagorean theorem would be true, right? So if that is a 90-degree angle, then 6 squared plus 4 squared will be equal to 100 squared, right? Sorry, 10 squared. I'm thinking ahead. Right?
Yeah.
Are you following me?
Yeah.
Well, is that true?
Yes.
36 plus 16 is equal to 100.
No.
36 plus 16, is that equal to 100?
No.
That's not a true statement. Therefore, that must not be 90 degrees. Otherwise, that would have come out, right? So we would say, no, even though that line appears to be tangent, it's not. Not. That line is not tangent. Does that make sense, everybody? Okay? So you're doing these ones. Okay, so we know if we have two tangent lines on a circle and they cross at one point, then those are equal, right? Those lengths are equal. So, looking at this one, this example. So right here is a tangent line, right? And right here is a tangent line. Do they intersect at one spot? Yes, therefore they're equal. And then once again, right here is a tangent line to here intersecting with a tangent line here. So they must be equal. And then this one's equal to this. Is everybody good with that? So let's go through and fill this in. So if this one, you kind of just work your way around the circle given what you know. So there's many different ways to do this. If this is 4, what's this? 4, okay. If this is 10, what's this? 10. Well, the whole thing's 17, so what would this be left with? 7. If that's 7, what's this? 7. Now, can't we find the perimeter? Adding up the outside. So we have 17 plus 10 plus 4 plus 4 plus 7, right? Does everybody see how to do that? Well, isn't that how we find a perimeter? Adding up the outside. Right? So you can add up, we have this side, we have this side, and then we're adding up perimeter. Does everybody see that? Okay, so you're finishing the worksheet, but you do not have to do number 19. You can cross it out. So if we were looking at something like this, and I said, is this a right triangle? Then you would do 2 squared plus 5 squared better be equal to 4 square roots of 5 squared. Now, it's 4 square roots of 5 all squared, right? if you do not type that in your calculator with parentheses, it will not calculate it right. Because we have to think about it. Isn't it 4 squared? What is 4 squared? 16. What's the square root of 5 squared? Don't root cancel out power. So 5. But if you don't type it in parentheses, it will not square the 4. But it is 4 squared, right, everybody? So you've got to type it in with parentheses as such around all of it. So a lot of times on your calculator, when you type it in, you'll go parentheses 4, and then you'll hit the square root of 5, and it will go like this. And then you'll close it and you'll square it. If you type it in like that, it will calculate it wrong, because it's only squaring this. So you'd have to double close your parentheses. So it's all squared. Does that make sense, everybody, on how to type it in correctly? Okay.